Here we are for the week 22 video. This is the week 22 test. There's only one test coming after this one. That's the week 27 test, and it will have only concepts 25 on it, 25-1 and 25-2. So you can get ready for those. All right, into the week 26 test. So the first question is a probability problem. And they ask you to make a sample space and then decide if Jose has 4 tiles in a bag, how many different combinations could you pull of 2 tiles? Now, when we discussed this in class, I pointed out there are a couple of ways to interpret this problem. So when I interpreted this problem, I looked at Jose's situation and I thought of playing Scrabble. You reach in a bag, you grab out 2 tiles. It doesn't really matter what order they're in. So as I interpreted the problem, this was the correct way to solve it. To say, all right, order doesn't matter. If you pull the tiles M and A, whether they're in your hand as M and A or they're in your hand as A and M, they're the same thing. So if that's the case, there are 6 combinations of tiles, and 3 of those combinations have no M. That gets us down to part B. The author of the problem, and a lot of you, interpreted it differently. You said, well, order does matter. If you pull out A and M, that's different than M and A. In that case, here were the answers. You could have M and A, M and T, M and H, A and M, A and T, A and H, and so on. That gave 12 combinations. And if you had those 12 combinations, there are 6 out of the 12 that have no M. I went ahead and gave credit for either way of interpreting this problem. If you interpreted it the way I did, I gave you full credit, as long as you had the work to show it. If you interpreted it as the author did, I gave you full credit, again, as long as you had the work to show it. The idea is come up with an ordered way of keeping track of the groups that you've used. All right, on to question 2. Here we go, question 2. So Will has marbles in a bag, 5 blue, 3 green, 5 blue, 2 green, 3 orange. He selects the marbles from the bag, 2 marbles without replacing the first marble. So he takes the first one out, records its color, sets it down on a table next to him, pulls the second one out. Since he's not putting marbles back in the bag, here's the thing that we have to know. When Will pulls that first marble out, there are 10 marbles in the bag. 5, 2, 3, 10 marbles in the bag. So the chance of getting that blue marble, this blue marble right here, chance of getting that blue marble ends up being 5 total blue out of 10. He doesn't put that back in the bag. So now when he goes to pick this orange marble right here, there are no longer 10 marbles in the bag. There are only 9 marbles in the bag. And 3 of them are orange marbles. So he has a 3 out of 9 chance. And then once we have those 2 independent probabilities, the probability of each item, we multiply them together to get our answer. We have the same situation in part B. Same thing. He pulls a blue and then another blue. Well, when he pulls that first blue marble, when he pulls the first blue marble right here, there are 10 marbles in the bag, and 5 of them are blue. When he pulls the second blue marble right here, since he didn't put the first one back, there are 4 blue marbles in the bag. Remember, he took out a blue one right there. There are 4 blue marbles in the bag out of 9 total. And once again, our way of then figuring out the overall probability is to multiply. We multiply the independent probabilities together, the 1 out of 2 for the first blue and the 4 out of 9 for the second blue. Multiply them together, we get 2 out of 9 total. All right, on to problem 3. Problem number 3, more probability. A bag contains blue, green, and purple marbles. we're told that the probability of you getting a blue marble is 1 out of 12. There's my blue marble right there, 1 out of 12. And the probability of getting a green marble is 1 out of 6, 1 out of 6 right here, which is the same as 2 out of 12. Why do I know it has to be 12ths? Well, because here's the thing I know. Anytime you add all the possible things together, the blues, the greens, the purples, you have to get one whole. It's just like if you're flipping a coin and you say, what's the chance of getting heads? It's 1 out of 2. What's the chance of getting tails? It's 1 out of 2. What's the chance of anything happening with that coin? Well, it's 1 out of 2 plus 1 out of 2, which is 1/2 plus 1/2 is 1 whole. So I know that this X right here, the purple marble, let me find a new color for that. The purple marble has to be whatever it takes to make this plus the X into 1 whole. So I go back and I figure out 1/12 plus 2/12 plus X equals 12 over 12. That's my 1 whole. That's my big 1. And I know that that is 9/12. Now you might just say, well, you skipped a step. So here's what I did. I said 12/12 is what I have to get all together. I'm going to take away the 3/12 that I got if I add 1/12 plus 2/12, and that leaves me 9/12, which is 3/4. And that is a likely event. 3 out of 4 is a likely event. On to the last. Sonia's flipping a coin. Now in this one, if you didn't do it when I asked you to, if you answered B and C, we have not discussed this idea of relative frequency, so I asked you to cross those off. When you answer A, what's the theoretical probability that a coin lands on heads? Well, the probability of heads is always 1 out of 2, just like the probability of tails is 1 out of 2. And if you add those together, you'd get 1 whole. So the answer to A, heads, 1 out of 2. Down to D. If Sonia flipped the coin a 51st time, what's the probability to land on heads? Well, you might have gone up here and said, oh, look, you know what? It's been heads 28 times and tails only 22 times. It'll probably be tails. That's not how probability works. The coin doesn't know what's happened in the past. So let me get you down to my notes here. No matter how many times the coin lands on heads or tails in the past, each time it is flipped, the probability of heads is 1/2 or 50%. If you flipped a coin 1,000 times and got tails, 900 out of those 1,000, and said, oh man, it's got to be heads a whole bunch to make up for that, the coin doesn't know it's been tails 900 times. The coin just, every time it flips, the coin just lands. All right, so the problems that you should really focus on, if you're getting ready for this next test, would be 25-1 and 25-2. Those are the types of problems that will be on the next test. Again, if you have additional questions, please make sure you bring them to me. And thanks for watching.